Assalamualaikum warahmatullahi wabarakatuh. We are from Group D. My name is Nur Atisha binti Muhammad Zariman, 2118676. For this assignment 2, we choose crime_data.csv where it shows the crime cluster, murder, assault, urban pop, and rape records of 50 states of America. Crime statistics represents crucial social indicators that can reveal underlying economic, demographic, and policy factors impacting public safety and well-being. Comparing crime rates and types of crime across geographic regions provides insight into factors driving criminal behavior and violence. Cluster analysis of crime data can detect patterns in criminal activity and enable government to develop appropriately targeted solutions. So the analysis utilizes a state-level crime data set to identify such clusters among 50 American states. Applying clustering algorithm to this rich dataset can achieve two key objectives, which are group states with similar annual recorded murder, assault, and rape counts normalized by population size. The segmentation identifies states with parallel crime environments, and the second objective is to analyze and describe key characteristics of the cluster identified through the analysis to highlight the correlations and causal factors between crime rates, urbanization, and other demographic factors. So next, this is our coding. So this is puzzling's part, which is EDA part. Here is the description of our data frame, and then here we check distribution of cluster. Then we check the distribution of all the features. This is crime cluster, murder, assault, urban pop, and rape. So this line here, we define a new variable x by selecting all rows and columns starting from the third column to the end of the data frame and converting the result to a NumPy array using dot values. Then we normalize the data set and we apply k-means on the original data. So we use AutoElbow to find the optimal number of clusters, and then we apply the k-means on original data. Next, we evaluate the performance using silhouette score. So this is the score for k-means on original data. Then we visualize the data using scatter plot. This is the scatter plot for k-means on original data. Next is my part, which is k-means on encoded data, where we apply autoencoder. So the autoencoder consists of an input layer, an encoded layer with a ReLU activation function, and a decoded layer with a linear activation function. The autoencoder is used to reduce the dimensionality of the input data to a two-dimensional latent space. Here we train the autoencoder, then we normalize the encoded data, then we apply k-means on the encoded data, where the n cluster is 3. Then we evaluate the performance also using silhouette score. So this is the score for k-means on encoded data. Then we visualize the data using scatter plot. This is the scatter plot for k-means on encoded data. Lastly is Patton's part, which is explainable AI using Shapley additive explanation. So here is the visualization and also this. That is all for our coding.
Assalamualaikum warahmatullahi wabarakatuh. I'm Fatih Shafika binti Syaifadali. I will explain about experimental setup. The experimental setup involves the use of two clustering methods, which are k-means and autoencoder based clustering. K-means is employed to group states based on their crime-related features, while the autoencoder is used to linearly separate the dataset. The justification for choosing these algorithms over others is by their widespread use, effectiveness, and also their ability to complement each other in improving model performance. K-means and autoencoder algorithms complement each other in clustering by leveraging their respective strengths. K-means is a centroid-based algorithm effective in partitioning data into clusters, but it may not handle nonlinear relationships well, so it needs autoencoders. Because through nonlinear mapping, it can greatly improve the representation of data for clustering by reducing the dimensionality of the input data to a lower dimensional space. It also can addressing the limitation of k-means in handling nonlinear relationships. So, the combination of the two algorithms results in improved clustering performance by using the strengths of both algorithms.
So for the next is discussion on the algorithm applied. We firstly move to k-means on original data. So from crime data set, which is consists of four columns, states, murder count, assault count, urban population percentage, and rape count. And for this data set, we use a method called k-means to group states are dissimilar in terms of these factors. And for k-means, we use the auto-able method to identify the optimal numbers of clusters to use for k-means, which is we got three to group based on similarities in crime rates and urbanization. And from that, we got the silver score for original data, which is 0.3188, indicating moderately separated clusters. And from the silver score and the scatter plot here, we can see that when we directly group states using the original data, there seem to be some natural clusters based on crime rates and urbanization. Next, an autoencoder was used to simplify the data into a lower dimensional representation. The autoencoder compressed the data into a two-dimensional space, which made it easier to visualize and analyze. The same number of clusters from AutoAble, which is 3, was applied for k-means for this encoded data. The silhouette score dropped significantly to 0.16, indicating the clusters were less separated in the encoded two-dimensional lattice space. Through this process also made the clusters less distinct, indicating that some useful information was lost. So for the explainable AI, we use a tool called Sharp to understand what factors were most important in the autoencoder's decision making. It showed that level of urbanization, which is urban population, and one specific crime, which is feature 3 that we can see from the image here, which indicates rape counts, were the most important factors to the model. But from the image here, we can see that the model struggles to use the other features, which is features 2 and feature 0, which is indicates murder and assault counts effectively. From this, we found that simplifying the data with the autoencoder made it harder to see the clear groups that were there in the original data. And the tool we use to understand the model, which is Sharp, show that even with the simplification, the model still focus on certain aspects, but it loses some of the connection to the original crime data.
From this assignment too, we learned that combining k-means and autoencoder-based clustering effectively groups states based on crime-related features, and autoencoders improve cluster separation by revealing underlying patterns and reducing noise through dimensionality reduction. Lastly, we learned that k-means provides efficient and interpretable clusters in the latent space created by the autoencoder. For our future work and improvements, for explore different autoencoder architectures, the current ReLU activation function and linear decoder could be replaced with other options to potentially improve latent space representation. And lastly, optimize optimize hyperparameters. Uh, we can experiment with different k-means cluster numbers and autoencoder hidden layer size, so it could further enhance the performance. So that is all from our group. Thank you very much.